Hello, hello, hello. What's that? Wait, go away. Hello, hello, and welcome to tutorial number 33 of our LTH tutorial series, where we're going to finish up looking into Monolith plugin for Grasshopper, and I'm going to show you a few bits and pieces, a few last things about Monolith, and also we'll design some, I guess, Vase, I don't know how to pronounce it, but we'll design some sort of an object with those bits and pieces. So without any further ado, let's begin. Oh, by the way, if you haven't followed these tutorial series, I would strongly suggest looking at tutorial number 32 and 31, just so that you don't get lost and understand what the heck is going on. So as per usual, I will first construct a base voxel field for my shape, for my viewport, right here. And I already covered this, but this is basically how big the box is, so we can plug in any size of the box we want. This is the resolution of the box, meaning how many divisions do we have inside. Right now it's 48 by 48 by 48. This is how many channels we have. So by default, it defaults to 2 channels, shape channel and material ratio channel, and that's perfect for us. If you would like to add any additional channels, you can with this input right here, such as flavor or sound or whatever. And then you have fill, what kind of a numeric value would you like to add to those channels by default. So by default it's set to 0, and that's great for us. Right now I won't be changing anything here. We'll come back to it. But for now I'll just have it as a default. Okay, and now I have covered bitmap sources right here, bitmap blends right here. So let's look at functions. Okay, construct function source. So if I drag this guy here, it asks me for a function, and I can actually, I can write sin x blah blah blah, like multiplied by u and so on. So I can write a function, but the nice thing about it is that here we have presets, right? So function presets, so I don't need to deal with that stuff. And in the presets, I can choose from quite a few of different functions, but for this tutorial I'll just show you the default one, the gyroed one, and you can mess around with these on your own. So I'll connect it like that, and immediately it asks me for 3 inputs. I believe, I'm not sure, but I believe these 3 inputs are frequency. So how many times does this gyroid pattern, how many times is it repeated within 1 by 1 cube? So here, if I write something like, for now let's write something like 5. 5, something small, but then we will increase the frequency quite a bit. So there should be like, the pattern should be repeated 5 times within this cube. Okay, so now we have our voxels, we have our source, so we need to add the values of the source to our voxels. So we need to populate those subdivisions with numbers, and I can do that by going to construct and choosing add sources, like that. I'll connect voxels to voxels, and for the source I will actually, for the channel I'll actually choose shape. So I'll connect my source to the shape channel because I want to show you how that gyroid is going to look like. And now we have our populated voxels. So these guys have numbers in them, these guys only have zeros in them, right? So these with numbers, I will go to outputs, go to get ISO mesh, connect my voxels to voxels input here, and yeah, and then there's of course a few more inputs that I need, but it will give me a mesh. So what kind of inputs do we need? We need to specify what kind of channel are we meshing. So to get a channel, I could either create a panel and just write in it that's fine, and just write a shape in it. Or I can go to outputs, get channel names, like that, connect voxels to the voxels input here, and then it just gives me the names. So I can connect shape, like just like that. Okay, and ISO value. So maybe, okay, let's start with, ISO values are usually between 0 and 1. So let's start with the middle ground, 0.5. I'll just connect it. And this is how it looks like, right? So that's a gyroid. So I lied, it's not, it's not repeating 5 times. It's actually barely repeating once. But if I increase the frequency here, you can see it becomes smaller or larger. So that's my bad. Okay, let's... Okay, sure, let's work with frequency of 10, maybe more, edit. Maximum frequency of 20. Let's work with 20. Right, so something like that. And let me display mesh edges. So that's a lot of polygons here. That's good to see. Yeah, that's about it, right? So you can mess around with different patterns and so on, and then you can get a nice 3D pattern here. Okay, so now what I'm going to do is I will disconnect my source from the shape, and I'll just kind of group this and call this 3D pattern. Oh, and a good rule of thumb is save document. This is quite an unstable plugin, 33. So it's nice to have your document saved so that autosave starts kicking in. Tutorial 2020 33. Save. Okay. Where were we? 3D pattern. So that's how you work with functions. Okay. And now we have construct geometric source. So let me just drag this guy here and construct. Let's use a geometric source instead. So let me do something very simple. I will just, should we do a box? Yeah, sure. Let's do a box. Small box here. Nothing fancy, right? So this box right here is a polysurface, and this guy is waiting, I believe. Let's see if it's going to complain. Set one brep, like that. Oh, okay, it's not complaining. I thought that it's gonna complain and say that, yo, you need to give me a mesh, but it's not. Okay. So we have a brep, and that's our input right here. So technically, without any other input here, if I just connect it to my shape right here, it's creating a ISO mesh around my box. And you can see that the created ISO mesh is larger than the box itself, and that's not great. Technically, you can't really make it fit perfectly. It's impossible with voxels because you work with the resolution, but you can come pretty damn close. So if I increase the ISO value to 0.9 or even more, you can see that if I increase it all the way to 1, it just disappears, and I believe this is going to say, yeah, it just says invalid mesh. But if I just kind of work with 0.95, let's do that. Come on, 0.95. It's, pretty close. So that's geometric input. Then you have strength. I usually don't mess with strength, but you have decay as well. So for instance, I can do a slider between 0 and 1000. Oh, shit. Decay, there we go. So that's with decay of 0, of course, everything is gonna become voxelized, so the box is gonna be infinite in size. But if I start increasing the decay, the closer I go, the higher I go, the closer it is going to be interpolated on the on the box. And now it's even becoming too small, right? So decay is how fast the influence of the box is falling off over distance. Decay of 20, let's leave it like that for now, maybe. We'll come back to this. And then we have type of decay. So there are like 4 types: linear, square, exponential, or power. And power of 3, I assume. By default, it's said to be exponential, meaning that it falls off quite fast as an exponential curve. And let's leave it as a default one. That's fine. I don't want to go too deep into these. We have a lot of stuff to cover in this tutorial without us messing around with that input. Okay, so we have a box and we have a gyroid right here. So let's see, actually let me hide the brep. Let's see what happens when we connect the gyroid from the source to the material ratio input here. Nothing. Oh, and actually I should probably just group this and call this geometry. Sure, geometry input. So there are 2 channels now in these voxels. One channel corresponds to shape, which is a box, and the other one corresponds to material ratio, either material A or material B, right? And we are not using material ratio right now. If I were to plug in material ratio to the channel that we are meshing, we could see that the pattern, right? Oh, by the way, here, this is ISO value of 0.95. If I decrease it, you can see how it's, how it's changing in thickness as well. That's a nice little thing. Okay. So we are meshing our box, but we want to use that gyroid pattern as a driving pattern for where we're using material A or material B, meaning that our box is going to be made out of 2 materials. And for now, I'll just show you just with color. So if I go to outputs and color mesh by ratio, if I choose this one, it will ask me to give it voxels. Sure, we have the voxels right here. It will ask me to give it a mesh, so that's my ISO mesh right here. And it will ask me to give it a channel for the color ratio. So that's our material ratio channel right here. Ta-da! It just colors it, right? I believe if I bake it out, yeah, if I bake it out, the colors stay. Hello, why are you inside out? Flip. There we go. If it looks inside out, you just flip it and then it works. Okay, so that's gyroid pattern on a box. Cool, but whatever. So let me delete the color mesh. We don't want to just color it. We actually want to split it, right? So split it into 2 meshes. One that has color A and the other one, or material A, the other one that has material B. So the tool that does that is called get mesh slices. This guy right here, which for this one we actually don't even need an ISO mesh. So let me delete it. Sure, I'll just delete it so that it's more clear what's going on. And let's see what kind of inputs it wants. It wants our voxels, sure. It wants a shape channel, sure. It wants a splitting channel, that's our material ratio, sure. Oh, it starts working immediately. And you can see, it kind of does its thing. That's whatever. It asks for minimum ISO value and maximum ISO value. So maximum should always be 1, at least in my opinion. While the minimum we can change. So let me go through between 0 and, or rather, let me just create a slider, 0.5. Because by default, I think it's set to 0.25. Yeah, 0.25. So if I connect 0.5, you can see that it sharpens up. If I come too close, it will break. Preview mesh edges. There we go. If I come too close, it will break. So let's do something like that. Okay, that's cool. Maximum ISO, as I said, let's leave it at 1. Number of meshes. This is set to be 5, meaning that it's going to create 5 meshes. Actually, we just want 2, so I'll just create a panel saying 2. Oh, come on, panel. Just be there. There we go. And then we can change the color, but do we care? No, not really. So now, if I bake this guy out, and let's just move it to the side, and I will take the red layer and move it away, we can see that it creates 2 meshes that are nested in each other, and they're split apart by our 3D pattern, which is already pretty damn cool, right? What else? Now I'm thinking, what else should I show you? Okay, so we are splitting our box with into 2 meshes with a pattern. Super. What if we want to say that the pattern shouldn't be always uniform? It should kind of taper out. Well, we can do that, and we can do that by, first of all, let me show selected. Let me show the box and kind of increase the size of the box a bit. There we go. Move it down. Make sure that every form that you use, make sure that the voxels are not touching the edges, right? That would suck. Actually, maybe I should. Let's rotate the box in a weird way. Like that. Okay, and now I will scale it down a little bit just to make sure that there is no clipping going on. Doesn't seem like anything's clipping. Okay, so we have that. So where do we go from here? Well, first of all, I want to increase, so let me edit and create a max value of 40. Takes so long. 40. So let me increase the density of this pattern, right? So now we have something like this going on, which is great. And actually, let me just double check one thing. Yeah, I just checked if my microphone was working properly. Okay, we're back. So we have a dense pattern here, but what if I don't want it to be all over this box, but I just want it to be in one corner? Well, I can do that. And I can do that in many different ways, one of which is, for instance, yeah, let me show you that one. Let me create a sphere and actually make sure that the sphere is somewhere here. Sure. So we have a sphere here, and let me create a geometric source. Again, construct geometric source, brep. So select my set1 brep, select the brep, connect it to geometry. So now I have my sphere as a source, and I can actually use it as a material ratio, for instance, and need to wait a little bit. Jesus Christ. There we go. So you can see that it kind of works, right? So now my one material is here and the other one is there. But I don't want to do that necessarily. Instead, what I want to do is I want to take this gyroid pattern and multiply it by this geometry sphere, geometry source. What that will do is it's going to trim away the gyroid pattern where the sphere has no influence, right? So if I go to construct and I choose multiply sources, it will ask me for voxels actually. So let me drag this out and use this add sources output as my voxels input here. And then it's going to ask me for either a shape or a material ratio to multiply, right? So I'm not going to mess around with the shape at all. I'm just going to mess around with the material ratio, right? So because a function comes in here, and then if I plug in my sphere right here, it's going to be multiplied. The function source is going to be multiplied by my sphere source. Hello, come back. There we go. Takes a while, but it does calculate. Okay, so now all I need to do is just replace this stuff with the new multiplication here, and as you can see, now the pattern tapers out from this sphere. Okay, that is done. So now let's make a cool design, because boxes are boring. So I am going to, actually I'll keep the box outline here, but I will select everything and hit delete. Okay, so let's say in front view, what kind of form should we do? Let's do a vase, a vase. So I'll take a control point curve and I'll just draw something like, what kind of vase should we do? Something like this maybe, just a little bit. Actually, proportion wise, it's kind of okay. Yeah, that's maybe a little bit wider here. Yeah, that's fine. So I have my profile curve here drawn like that, and I will just simply revolve around 0.0. So I just type in 0, enter, press enter to use C-plane Z-axis direction. Yes, we will use Z-axis direction, enter. Make sure that you're doing this in perspective view, by the way. Start angle 0, sure. End angle 360, sure. I have a vase and it's inside out, but that's fine. I'll just flip it around. Okay. And I will cap it, but actually I want the top part to be open, so I'll just use extract surface, extract it and delete it. Okay, so now we have our base shape. So let me right click on the B-rep, set one B-rep. Okay, and actually I'll save it just in case. And let's look at how it actually works. So I will not be using a material ratio for now, neither here nor here. I will just be straight up using voxels. And this is how it looks, and you can see it's clipping right here, so I don't want that to happen. And to make it not happen, I will just scale down the vase so that it kind of fits. Okay, and there's a hole there. Sure, it's a vase, right? Nothing too fancy. Okay, so now for the material ratio. Well, if I straight up connect my gyroid to the material ratio input, it immediately works, right? Immediately creates a pretty nice looking vase mesh for me. And then I can create, again, let's go for a sphere. And actually this time I'll do that in top view. So let's say a sphere that is right here, maybe on this portion of the vase. Okay, and I will just set one rep, There we go. And I will multiply. I will multiply. There we go. Now we wait. As you can probably tell, this is not the fastest, not the fastest tool, but it is what it is. Okay, so we do get a little bit of pattern there, but let me actually increase the sphere just like that to get more, to get a bigger area of the pattern. Or we could use 2 spheres, you know, you can do whatever you want. But I'll do something like this. Come on. Is it? Yeah, there we go. Okay. So now we have our pattern here, and I think it looks quite cool. Let's actually, where's my grasshopper? Hello, grasshopper? There we go. Actually, let's make it, so we have 2 meshes, minimum, maximum color. Let's just look at them for a bit. That and that, move it to the side. Let's see. Yeah, it looks fine. Ah, yes, of course, mesh colors. But yeah, that seems to be a-okay. Yeah, that's something that I can work with. Can we make it? Yeah, later on we'll probably make it to something like this, but that's later. Okay, or even squish it further. We'll see. So we have it working, and now it's time to actually just increase the resolution and yeah, and call it a day. Well, not really. I will need to show you a few more tricks on how to make this 3D printable. So let me increase the resolution, and while it's doing its thing, I will talk over it. So right now the resolution is set to be 48. I will amp it up 2 times, so I'll amp it up to 96 actually. And while this is doing its thing, let me talk about the benefits of, well, not the benefits, but how this can be used. So when you get these 2 meshes, right, you can specify 2 different materials for your 3D printer. So prusa printers with MultiMaterial unit, forgotten, like a bunch of dual nozzle extruders. There's also tool changer by E3D. All of them can print with 2 materials at once. So for instance, one material can be transparent while the other one is not, and this is the most basic one. But also think about structural performance, right? One material can be soft while the other one is hard, and so on. So you can do a lot of really crazy stuff with this approach, where you create a form that has 2 materials incorporated into it, right? And it behaves in a certain manner, right? So this is an additional layer to the form, right? Additional information layer to the form. I really enjoy it. It takes quite some time though, and I don't have that kind of 3D printer right now at home, so I can't really test it out. But there are a few things with Monolith plugin that prevents us from testing it out. Why is this crashing? Hello? So there are a few things with Monolith plugin that are preventing us, from testing it out, but I will show you how to work around them and how to make this geometry actually 3D printable. Hello, please. Let me pause the video, and then once it's done, we will come back. Okay, there we go. So it took a while, like 4.5 minutes. For some reason, the multiplication really takes a long time to calculate. So if you don't need to use it, you don't, just don't use it, I guess, is my suggestion. But we end up getting something like this. And actually, it's pretty hard to show you how it looks like because of the vertex colors that we have. But I believe if I go to display, if I go to properties and let me change the red material to a different, let's say, glass, sure. Glass, and let's go for Arctic view. Will you show? Yeah. And then the blue one, let me change it to plastic color gray. What? Hello? Sorry, I'm sorry, what? So you are plastic and you are glass, but it's still bugging out. Okay, fine. If it's bugging out, we can fix that here. Where we have two meshes, to get rid of material colors, I will just deconstruct those meshes, deconstruct mesh, and I will construct mesh. So I'll reconstruct them like that, and then I'll just combine and clean, just clean it up a bit. There we go. And now, as I bake this guy out, this is going to be clean, without any colors attached to the vertices. That's a nice little trick. Actually, maybe I should keep it. I'll just add the data dam here, just so that you don't need to wait for this to calculate every time. There we go. Okay. So, where were we? Arctic view. We have this guy. Let's let's go to properties and use layer. This is gonna be glass. I mean, come on. It's pretty cool, isn't it? And then I can use this one as plastic. Yeah, plastic is maybe red. Yeah, that works. So we made a pretty cool vase, right? And I think if I, yeah, this looks nice. So I'll use this one for the intro and the thumbnail and so on. So we have a vase. There's one thing though, one problem with it though, it's not 3D printable. And that comes from, let me actually, how do we do this? Let me make a copy of this and just drag this out here. So we have two parts, right? If I select one of those parts, or do I even need to? I can just zoom in and show you. See how these edges are messed up? Yeah, that's a huge problem with Monolith, is that it can't close them properly. You can fix it with Kangaroo. So you can fix these meshes with Kangaroo by forcing them to kind of lock back on the seam, because the discrepancies are not that far apart, right? So you would just need to kind of snap these vertices together. So you can definitely do that with Kangaroo. That's for sure. Or I will do it quick and dirty way, because I'm trying to make these tutorials less than an hour. So I'll try to do it quick and dirty way. Let's see. if we have, and I'll do that without this portion right here. So let me save this. Then let me create a new file, or rather save it as a new document file, tutorial 33-2 or dash printable. Hit save, and now we're going to make this into a 3D printable one, but without the multiplication, because that is taking way too long to calculate. So we'll do that without the multiplication, meaning that the whole pattern is going to be throughout the whole mesh. You can do that with multiplication as well, of course. It's just I don't want to wait that long. Okay. So we have two meshes, right? And we have two channels. We have a voxel grid and we have two channels. Shape channel and we have material ratio channel. And the way this voxel grid works, and by the way, this is going to be a very, not very advanced, but this is going to be an advanced tutorial, meaning that if you are a newbie with Grasshopper, I would suggest kind of sticking to the first part of the tutorial, and this is for more advanced users. Because it gets pretty intense. So we have a voxel grid inside, right? And each voxel contains two numbers, one for the shape and one for the material ratio, right? And when the ISO values hit those numbers, it will create a mesh polygon using Marching Cube's algorithm. So the way we kind of mitigate this is, first of all, I delete this whole damn thing. Let me hide this. The way we mitigate the fact that by default Monolith is not capping or not closing the edges properly is by first taking the voxels of the shape and then taking taking the numbers of the shape channel and then taking the numbers of the material ratio channel and asking whether or not the numbers in material ratio channel are larger or smaller than 0.5. And it only works with 0.5, don't worry about it. So first of all, material ratio, and this is just channel names, I don't need that, go away. What I need is the numbers themselves for each voxel. So if I go to transform channels and I go to get voxel values, or choose to get voxel values, it will give me all values, all 884,000 values for the shape channel and 884,000 values for the material ratio channel. So for material ratio, is that a minus? Yeah, sure, whatever. For material ratio, I will ask, is the number larger than 0.5? Or let me just write it like that. That's the key number here. This method only works with 0.5, right in the middle. Is it larger than 0.5? So it says yes, no, yes, yes, no, whatever. And then we will say that, okay, if it's larger than 0.5, then the numbers in the shape channel should be changed to 0, meaning that what's outside of our gyroid surface in the shape channel should become 0, like empty voxels. So I will just create a number 0 and I will repeat it. Repeat. That's repeat data. I will repeat it. How many times? Well, as many times as I need. 884,000 blah 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 times. So I'll just measure list length, which will give me the number of how many times I need to repeat it and connect it to my length input here. So I have 884,000 numbers and I have a matrix of true and false statements. Not a matrix, but you get what I mean. So then I can use pick and choose tool here, which can use this pattern of true and false statements as an input, and then everything that is true. Hello, why are you so slow? I should probably do this with less resolution. Yeah, let's do this with less resolution. It's gonna take too long. So let me drop this down to 40, something like that. There we go. So everything that is false is going to get a number from within 0 and 0 input, and everything that is true is going to get a number from this list that I'm going to plug into input 1. So everything that is false means that everything that is out of the freaking... I can do this, just give me a second. Out of gyroid pattern, so negative space within the gyroid pattern. So that should be that should become 0, like that, right? So it will get from the list of zeros that I have here, and then everything that is inside of the gyroid pattern should get the numbers from the shape channel, like that. Okay, so we have that going on. So now we have a bunch of numbers. Okay, what about it? Well, we can go to outputs, get ISO mesh, right? Again, I can use the voxels. Let me drag this down a bit. I can use the voxels. I can use the channel, my shape channel, and I can use the ISO value of 0.5. Again, magic number. Always use 0.5 for this approach. And wait, no. Oh crap, sorry. My mistake. So ISO value and channel are fine, voxels are not, because right now we have changed the values of the voxels, right? But we haven't put them back into the voxels. So if I go to transform channels and I go to set voxel values rather than get, I can use the old voxel is here. I can say that the channel is going to be shape, and the values are going to be the replace, the picked and chosen values here. And then I just plug in the voxels to the voxels input here. And this is an invalid mesh. No, it's a null. Ooh, why are you a null? You are a null because I am stupid. Here it's asking me for a channel and I'm giving it a bunch of numbers. So instead, here I need to go to outputs and choose get channel names, like that. Hello, get channel names. Okay, sure, I will go here and get channel names. It's a little bit buggy, and I'll just connect shape to channel input here. Okay, finally. So now, null. What do you mean null? You can't be null. Okay, let's start from the scratch, from the beginning. We have the shape, that's our source, that's our voxels. First of all, let's see if it straight up will work like that. Yes, it does work like that. It's a fat boy, but it does work. Maybe we need to make it less fat. Oh, by the way, I almost forgot. To make it less fat, you just increase the decay. So I'll use decay of 600 or something like that. Should work. Yeah. With 600 it works. Kind of starts breaking apart, but that's fine. Okay. Now with these voxels it doesn't. Oh, but this is a null output. Why are you a null output? You get the voxels here. You get a channel. That's because I'm being stupid again. I'm using numbers for the channel input again. God damn it. Come on. Concentrate. There we go. So now it works. And you can see it breaks down quite a bit. That's because we're using a pretty low resolution with pretty high decay value. So I'll decrease the decay for now a little bit, just to make it thicker, and this is what we get. And I can increase the resolution, but for now I'll keep it, you know, kind of messy. It's fine. Everything is fine. Okay. So we have one ISO mesh, right? We need to do another one, right? So I will use get ISO mesh again. And let's color this. Preview, custom preview, swatch. Let me just make it blue. There we go. So another mesh, right? Voxels are going to be the same voxels that we have, or are they? No, they're not. For voxels, where we set the values, I will need to set the values again. Set voxel values. So it's going to be a new set of values, where I'm going to also pick and choose the values, like that. And the pattern, or rather 0, is still going to be 0. 1 is still going to be my shape channel, but the pattern is going to be an opposite of what I used before, right? Because I want to invert it. So I can just do, or can I? Channel invert. What would happen if I... Sorry, this is just me messing around, but bear with me for a second. If this works, I will explain. If it doesn't, no, it doesn't. Okay, I won't explain it. Don't worry about it. So, and let me disconnect it. I will guide you through this part as we come to it. Okay. So pick and choose, we have our logic, like true and false statements here. So I will just invert it by using gate not, like that. I'll use that as a pattern. Rather, maybe I should use this. It doesn't matter. It will skip a few voxels, but that's fine. Or maybe, yeah, let's just use more or equal statement. Okay, so we are setting inverted values to these voxels. So the voxels come from right here, from the start, and the channel that we're using is going to be the same shape channel. Hello, shape channel. Okay, and now we have our voxels, so I just connect them like so to our new ISO mesh tool, second ISO mesh tool. The channel that we're going to be meshing is again going to be our shape channel. ISO value is again going to be 0.5. Can't stress this enough. 0.5 is the key value here. And then I'll just do a custom preview for this bad boy here as well. Let's make it transparent like that. Display, preview mesh edges. So we end up getting something like this, right? Looks like shit, but this is 3D printable, meaning that everything is a closed mesh. There are no openings here, so the slicer software can slice through it and actually print it out. To make it nicer, if you want to make it nicer, all you need to do is just to increase the resolution, right? So right now the resolution is set to 40, and I will increase it to 96, 100, let's go for 100. So I'll just save the file here and save this one here, because it's a little bit crashy when we try to do it. And again, sorry for rushing through here. I will increase this to 100 and let it run for a second. So I rushed through this second part because it's not necessarily that important, and usually people who need this second part are the ones that already are able to solve this kind of a problem by themselves. So I just showed my take on it and how to operate within the same Monolith plugin to solve a problem imposed by the Monolith plugin, which I think is quite funny. Other than that, while this is running, I will be doing live streams. So, and those are not going to be Grasshopper related, because during live streams I want to just chill. So I'll probably just do some sculpting or some drawing, some 3D modeling, something like that. Just some fun live streams. So check those out. You know, if you see that I'm live, just swing by, say hi. And other than that, we are quite done with. Oh, there we go. We are quite done with this tutorial right here. And that's the final tutorial of Monolith. I will be, of course, coming back with more tutorials in the future, but for now this set is done. So let's just double check if I'm lying to you guys or not. So we have this form here, and one of them is inverted flip. There we go. The other one is also inverted flip. Okay, so we have this form here, and if I use a clipping plane, you can see it clips properly. Right, so everything is nested together nicely. If you use an ISO value of not 0.5, something else, then the sections here will not match up that nice. And it seems like they are not matching up, but that's fine. The more you increase the resolution, the better it's going to be. So here I just chose 100. For 3D printing, I would probably use, well, depends. If you're using FDM 3D printing, I would use something like 156. For powder-based 3D printing, I would push it to 250 and then just, you know, give it a few hours to calculate. But that's that. I hope everyone enjoyed this, and I will see you guys. Wait, Arctic view. Yeah, yeah. And I will see you guys in the close future. Later. Goddamn, I'm so bad at this. The files are going to be available for my Patreon supporters. If you're lazy and you don't want to kind of copy and paste what you see on the screen, you can support the channel on the Patreon, link in the video description, and get the files, you know, for free, kinda. Yeah, you get what I mean. Yeah, that's that. Now it's really bye. Bye.